I'm Anil Kumar. Welcome to my series on solving previous test papers. Let me thank all the students and some of the subscribers who have shared their test papers with me so that I can provide you with similar questions. In this particular video, we'll talk about calculus. We'll begin with the very first unit, Introduction to Calculus, where most of the questions will be related to limits. I have picked a few questions from IB test paper of my student. So that's how the paper was. And this brilliant student scored more than 90% marks in most of his exams or tests. Now let's talk about the questions which I have selected. The very first question here is sketching a piecewise function. And from that piecewise function, as you can see, we'll find the limits at different points. And we'll also understand the concept that left side limit should be equal to the right side limit for limit to exist. And then we'll learn the concept of continuity. If the limit exists and its value is same as the value of the function, then the function is continuous, right? In question number 2, we'll talk about difference quotient. Now this is fundamental to our understanding of calculus. From here, we develop the concept of slope of tangent line and derivatives, right? So we'll explore that as a part of our question number 2. In question number 3, it is knowledge-based question where we are going to find limits of 6 different functions. As you can see, you can actually pause the video at any time, copy the questions, work on them, and then look into my suggestions. Question number 4 is based on one-side limits where we have used absolute function. Many times you'll find that the limits for absolute functions do not exist. In this particular case, you may like to prove it algebraically and also show it on a graph. Question number 5 is about properties of limits. So as you can see, we are given limit for a function as x approaches 4, and we need to find the limit of a complicated function shown here, right? Question number 6 is kind of important as here we get into finding equation of a tangent line using the concepts of limits. And question number 7 is an application question where we'll try to work out average rate of change and also the radius when the average rate of change is given to us. So that gives you a wide variety of questions to help you review the whole unit fairly. I hope that makes sense. Now let's begin with their solutions one by one. Question number 2. Consider the difference quotient 5 times minus 2 plus h whole cube plus 40 divided by h. Find the equation of the function. What does the difference quotient signify? Explain its meaning when h approaches 0. Now this is a fundamental question on which the whole unit is based. Now let's try to figure out the equation of the function. Let me first talk about difference quotient, right? So when we say difference quotient, we are talking about f of x plus h minus f of x over h. So that is the general form of any difference quotient. When we are given a point, then we are substituting the value of x. In our example, we have 5 times minus 2 plus h whole cube plus 40 over h, correct? So what do you see here? You can correlate and say, well, the x value is minus 2, correct? As far as the function is concerned, the cube here, right, gives you an idea. So you can say that the function f of x seems to be 5x cubed. Does it make sense? Well, we can confirm that if we substitute minus 2 and if we get minus 40, then it is correct. So let's figure it out. What is f of minus 2 equals to? 5 times minus 2 whole cube, and that is 5 times minus 8 is indeed equal to minus 40. Right? So that means that we're trying to use difference quotient for the function 5x cubed at x equals to minus 2. Or you can say at a point which is minus 2 minus 40. Perfect? That is what we're trying to do. Okay? So we get the solution of the first one. Find the equation of the function. So the equation of the function here is f of x equals to 5x cubed. Correct? And that is the justification which we have given. Part B. What does the difference quotient signify? So this was part of part A. Now let's talk about part B. What does difference quotient signify? Now basically, if you see difference quotient in this example, let me just extend this, since learning is most important as we go through the solution of these questions, right? So let us say the function is 5x cubed, which is kind of like this, right? Now when we are saying that this difference quotient thing is at minus 2 and h is some value very close to minus 2, right? So what we are trying to say here is that it's kind of like this. So where this point here, let us say, is minus 2, correct? So h is somewhere close to minus 2. So it basically gives you slope of a secant line, right? So the point, the difference quotient basically gives you the slope of a secant line, right? So let me write down here what difference quotient signify. So we can write difference quotient signifies slope of a tangent line, I should say secant, right, between 2 points. Now in our case, the points are, we can say point A is minus 2 minus 40 and point B is h f of h. Okay? So that is the other point where h could be slightly more or less, right? But normally close to minus 2. That is what it signifies. Perfect. So that is how you could answer this part. Now let's look into part C, which is explain its meaning when h approaches 0. So now when h approaches 0, that means h is very, very close to this. So we're talking about a point which is extremely close to this. So the situation now becomes, the secant becomes kind of a tangent. Do you see this part? So at this stage, secant approaches tangent. Do you see that? And the expression could be written as limit h approaches 0 for f of x plus h minus f of x over h. So that is how we get into the concept of limits. And in the next unit, we'll talk about derivatives, which is just this, slope of a tangent line at a point, right? So this basically is a concept of slope of tangent at a given point. Do you see that? Right. And in the next unit, we'll learn about derivatives, which is basically the same thing. Right. So I hope you understand its significance and also the question as such. This question is extremely important from test point of view. Now let's take up question number 3. Here is question number 3. We'll discuss how to find limits of functions. So we have 6 parts in this particular question. You can always pause the video, answer the question, and then look into my suggestions. We need to evaluate the following limits. Limit when x approaches pi for 3x. Limit when x approaches square root of 2 for 5. Limit when x approaches 2 for 2x square minus 7x plus 6 over 4x minus x cube. Limit when x approaches 4 for 3x cube minus 12x square plus 5x minus 20 divided by x cube minus 64. Limit when x approaches 4 for 4 minus square root 12 plus x divided by 4 minus x, and limit when x approaches 27 for x minus 27 over cube root of x minus 3. So we are going to use different concepts learned as we go through these 6 questions based on limits, right? So here we will use substitution, in this case rationalization. In these 2 cases we'll factor and simplify, and first 2 are straightforward, correct? So here we have 3x and x equals to pi. So how do you find this limit? Just substitute pi there, so we get 3 pi as our answer. Now in this particular case we have limit. The function is a constant function, right? Remember, this is a constant function, correct? So it is always going to be 5, whether you check it at square root 2 or any other number, correct? So that is how we do them. Now others will do it on separate sheet of paper. Meanwhile, you can always pause and answer these questions. So now let's take up part C, which is limit when x approaches 2 of this particular function. Now if I write 2 in the denominator, I get 8 minus 2 cube is also 8, right? So it is denominator 0. If I write 2 in the numerator, you will find that that is also 0. So this is 0 over 0 form. It is indeterminate. So we will actually factor and then solve. These zeros are because of a factor. So when we factor, we'll get a common factor in numerator and denominator, cancelling that and then substituting 2, we should get our solution, right? So the question here is to find limit as x approaches 2 for 2x square minus 7x plus 6 divided by 4x minus x cube. We could write this x approaching 2, right? So it is limit when x approaches 2. So it's question of factoring, right? 6 times 2 is 12. So we need to get product of minus 7. So what could the 2 numbers be? 4 and 3, right? Both negative. So we can write the numerator as 2x square minus 4x minus 3x plus 6. Now some of you can actually do the factoring separately and then do the needful, right? So that is also possible. Let's take x common here. So let me take minus x common. So if I take minus x common, I could write this as x squared minus 4. Perfect. Okay. So we could rewrite this as limit x approaches 2. The numerator, taking 2x common, we have x minus 2. And here taking minus 3 common, we get x minus 2. So that is what we were expecting, right? A factor of x minus 2. And this could be written as x plus 2 times x minus 2, correct? We have nearly factored it. Let's finish it off. So now we have 2x, 2x minus 3 times x minus 2. X minus 2 is a common factor, correct? Over minus x times x plus 2 times x minus 2. So we can now cancel these 2 common factors. That really means we have a whole, right? So that means just a note that gives you whole at x equals to 2, right? So whenever you cancel, you have to write x is not equal to 2. Is it okay? So we have an equivalent expression here. So finding limit with an equivalent expression is the whole idea. So now we have an expression which does not have this factor which was making it 0. So let's rewrite this. We have 2x minus 3 over minus x times x plus 2. Substituting 2 here, we get 2 times 2 minus 3 over minus 2 times 2 plus 2, right? So that is 4 minus 3 over minus 2 times 4. That is 1, this negative, let me write here, over 8. So we have the limit as negative 1 over 8. So the limit of the function is minus 1 over 8. So that is how we can actually solve such a question. So I hope that makes sense. Now let's take the next part, which is question 3D. We need to find limit of the given function as x approaches 4. Again, if you substitute 4 here, we get 0 over 0. So this is also 0 over 0. So what we are going to do? We are going to factor. So let's do it. So we get limit x approaches 4. The numerator, you can see that these two terms have 3x squared common, and this has 5 common. So let's do that. So we could write this as 3x squared, and in the bracket we get x minus 4. Here if I take 5 common, we get x minus 4. Denominator, we have cube, right? 664 cube is basically cube of 4, right? So a cube minus b cube formula will be applied. Let me write down here formula for a cube minus b cube, which is a minus b times a square plus ab plus b square, correct? So that is the formula which we are going to use to factor it further. Now, so b, which is 4 cubed, so we get x minus 4 times x square plus their product, which is 4x, plus square of 4, which is 16. So that is your denominator, correct? Now, in the numerator, we have x minus 4 as a common factor. So I'll take x minus 4 common. We are left with 3x squared plus 5. Denominator has x minus 4 as a factor. We have x squared plus 4x plus 16 as the other factor. Now, you can cancel the common factor. So again, there's a whole at x equals to 4, right? So we get limit x approaches 4 for 3x squared plus 5 over x squared plus 4x plus 16. So when you substitute 4 here, what do you get? 3 times 4 squared plus 5 over 4 squared plus 4 times 4 plus 16, right? So this is 16, 3 times 16 plus 5. You can do this math. And we get 3 of these 16s, right? So 3 times 16. This is also 16, 16 and 16, correct? So that's what you get. And our answer now is 6, 8, 18 and 148, right? Plus 5 over, we have 3, 6, 18, so we have 48 here. So the answer here is 53 over 48, correct? So that becomes the limit of this particular function as x approaches 4. Part E. Evaluate limit as x approaches 4 for 4 minus square root of 12 plus x over 4 minus x. So we need to find limit as x approaches 4 for 4 minus square root of 12 plus x over 4 minus x. So again, if I substitute 4 here, this is 16, the square root is 4, we get 0 over 0. So in this particular case, we'll do rationalization. So wherever you have square root, we should do rationalization. Now since the square root is in the numerator, we'll rationalization of numerator. What does that mean? It really means that we have to multiply and divide by the conjugate, right? So let me show you what it means. So we have this function 4 minus square root of 12 plus x divided by 4 minus x. We'll multiply and divide by its conjugate, which is 4 plus square root of 12 plus x over 4 plus square root of 12 plus x. Is that clear? So when you do so, we get difference of squares, right? So since you know that a squared minus b squared is actually a plus b times a minus b. So we have situation a minus b times this. So what we get is difference of squares. So the numerator now becomes 4 square, which is 16, minus square of this, which is 12 plus x, correct? Denominator, we'll write both the factors. 4 minus x times 4 plus square root of 12 plus x. Now, let's simplify the numerator. We get limit. As x approaches 4, we have 16 minus 12 as 4, so we get 4 minus x. Right? 16 we get 4 minus x in the numerator, divided by 4 minus x is a factor which can now be cancelled. That was the idea. Since it was 0 over 0, we knew there is a common factor, which is 4 minus x or x minus 4. So it could be cancelled. So rationalization helped us to do it. So we have limit x approaches 4. And now what we get here is 1 over 4 plus square root of 12 plus x. Correct? Now we can substitute 4 here. So we get 1 over 4 plus square root of 12 plus 4, which is 16. So we get 1 over 4 plus 4, right? Or we get 1 over 8 as our answer. So the solution for this is 1 over 8 is the limit for the given function as x approaches 4. Now let's take the last question of this series. We need to evaluate the limit x approaches 27, x minus 27 over cube root of x minus 3. So if I substitute 27 here, we get 3. 3 minus 3 is 0. 27 minus 27 is also 0, right? So it is again 0 over 0 form. In this case, we'll use substitution method to find the limit, correct? So let us say that let u be equal to cube root of x. In that case, u cube will be equal to x. This is first thing, correct? Second is the limit. So when x approaches 27, right? So u approaches what? U approaches cube root of 27, correct? So u approaches 3. Do you see that? So these things are important. So whenever you do substitution, you have to also see how does the limit approach, right? So let's rewrite the equation with this substitution. So we could write this as limit u approaches 3 and x is equal to we wrote u cube is this x, right? So instead of x, I'm going to write u cube. So I'm going to make this substitution for x. So we get u cube minus 27 over, we have written u as cube root of x, u minus 3. Do you see that? So again, we'll use the factoring formula of a cube minus b cube to solve this question. So we could now write this as limit u approaches 3, and the numerator could be written as u minus 3 times u square plus product of these two, which is 3u, plus square of 3, which is 9, over u minus 3, correct? So u minus 3 cancels, so we get limit u approaches 3 of u square plus 3u plus 9 over 1. Let me write like this. So as we can see, this cancels. Second, about the factoring part, so if it is a cube minus b cube, as I said earlier, could be written as a minus b times a square plus ab plus b square. So we use this formula to factor. Perfect. Now we can substitute u to find the limit. So we get 3 square plus 3 times 3 plus 9, which is, so these 3 9s, right, which is equals to 9 times 3, 27. So the answer is 27. So that becomes the solution for the given question. Perfect. So this limit is 27. So I hope you understand now how to find the limit of functions and how to use these different techniques. So we've effectively utilized three techniques here: factoring, rationalization, and substitution. In all these three cases where we used these techniques, the functions were indeterminate, since substituting the value gave us a form 0 over 0. 0 over 0 also indicates that there is a common factor in numerator and denominator. These techniques helped us to identify those factors and simplify the expression. So that is the whole strategy behind it. So I hope the concept is absolutely clear. Question number 4. Using one-sided limits, show that limit when x approaches 3 for absolute x minus 3 times x plus 1 divided by x minus 3 does not exist. Sketch the graph. So we are given an absolute function, absolute value of x minus 3. Let us first try to understand this part. Now this function is defined as x minus 3 when x minus 3 is positive or when x is greater than or equal to 3. But when x is less than 3, then this value is negative of that. So let me write this as negative x. So when I do negative, both, I could write like this, correct? So negative of x minus 3. So that is how the absolute function is defined. So therefore, we should actually solve the particular question in two parts. One, where we're talking about x being less than 3, and the other where x is greater than or equal to 3, correct? Now if x is less than 3, in that case the question becomes limit, and what we have here, x minus 3 absolute value will be negative x plus 3 or negative of x minus 3, right? You could say that. Let me write like this, times x plus 1 over x minus 3, where x approaches 3 is the limit we are interested in. Now this is negative of x minus 3, so that goes negative one time. So we could write this as limit x approaches 3 of negative of x plus 1, correct? Substituting 3 here, we get the answer as minus of 3 plus 1, which is negative 4. So the limit from the left side, right, which is, I should say, x approaches 3 minus, to be very specific. So that is the limit from the left side. So let me write this as left side limit. That is limit when x approaches 3 from the negative side of the given function is equal to minus 4. Is that clear to you? Now let's find the limit when x approaches from the positive side. So in that case, I could write this as limit x approaches 3. That 3 plus indicates we are approaching from the positive side. And what we have here is absolute value, which I'm going to write as x minus 3, right? So let me write this as x minus 3, right, times x plus 1 over x minus 3. So that is what the absolute function is equal to when x is greater than or equal to 3. This could be written as limit x approaches 3 from the right side as x plus 1, since these two factors cancel. Substituting, we get this limit as 4, right? So this is like 3 plus 1, which is 4. So what we notice here is that the right side limit equals to plus 4, correct? Now since left side and right side limits do not match, the limit does not exist, right? So that is the important conclusion. Now since these two limits are not equal, correct? So we can write here, since left side limit is not equal to right side limit x approaches 3 does not exist. Is it clear? So that is how you're going to explain it. So we have done the major part of it. The other part here is to sketch the graph. Okay, so how do you sketch this particular graph? Now from this simplified expression, it's kind of simpler to sketch the graph. So let me just make a rough sketch here. I would like you to do the same on a proper graph paper with some values. So the critical point here is at x equals to 3. So when x is less than 3, the function basically is, let me write on this side, the function is basically simplified as minus x, this is what the function is, right? Minus x minus 1, correct? Or minus of x plus 1, correct? So when x is less than 3, then in that case, we are talking about the function which is effectively equal to minus x minus 1, correct? That is what the function is. And when x is greater than or equal to 3, in that case, the function is x plus 1. Do you see that? That is the function, right? So if I take 3, which is included here, let's say this point is 3 for us, right? So 1, 2, and 3. The y value being 3 plus 1, 4. Let's say 1, 2, 3, 4. So that is the point which is included. It's a straight line with a slope of 1. So the function will be sketched like this. On the other hand, when I'm approaching from the left side, then this will give me the value as minus 4, correct? So at 3, I have a value which is 1, 2, 3, 4, minus 4, a whole here, right? And if I write 0 for x, I get minus 1. So it goes through this point, correct? So I could draw this as perfect. So that becomes our function, right? You can see this is the jump discontinuity. Do you see this part, right? So the limit really doesn't exist. If you are approaching from the right side, you are approaching a value which is plus 4, and from the left side it is minus 4. And there is this jump discontinuity, right? Do you see that part? So that is how you could explain and understand one-sided limits. I hope it makes sense. Let's move on and take question number 5. Question number 5. Show using the properties of limits that if limit x approaches 4 for f of x is equal to 3, then limit x approaches 4 for f of x whole square minus x square divided by f of x plus 4 is equal to minus 1. So we are given the limit of the function as x approaches 4. We need to find limit of this complicated function, right? So let's begin with this complicated function, which is limit x approaches 4 of f of x whole square minus x square over f of x plus 4. Perfect. We will apply the properties of limits to find our solution. So properties of limits state that this limit could also be written as limit x approaches 4 for f of x whole square minus limit x approaches 4 for x square divided by limit x approaches 4 for f of x plus limit x approaches 4 for 4. Perfect. That is how you could write it. So now we know what the limit of f of x is as x approaches 4. It is 3. So we'll replace this by 3. So we get 3 square minus x square when x approaches 4 will be 4 square divided by, this limit is given to us as 3 plus constant 4. So that gives you 3 square is 9 minus 16 over 7. Now 9 minus 16 is minus 7 over 7 is minus 1, which is the right side, correct? So that is how we can show that the limit of the given expression is minus 1. Perfect. Now let's move on and take question number 6. We need to determine the equation of tangent line to the curve f of x equals to 2 over square root of x plus 3 at x equals to 6. You can always pause the video, answer the question, and then look into my suggestions. Now at x equals to 6, what is the point? That means what is f of 6 equals to? So if I substitute 6 here, I get 2 square root 6 plus 3, which is 9. And that gives me 2 square root of 9 or 2 over 3, right? So that is the value at 6. That means we have a point which is 6, 2 by 3, correct? To find tangent, we'll consider another point Q, which is very close. Close means we'll take a value where the x value will be 6 plus h. You get the idea. Now if 6 plus h is the x value, then what is the y value? Let's calculate that also, right? So if 6 plus h is the x value, then what is f of 6 plus h? So we'll replace 6 plus h here. So we get 2 over square root of 6 plus h plus 3, which basically is 2 over square root of 9 plus h, correct? So that becomes the value of y. So I could write this point Q as 6 plus h and 2 over square root of 9 plus h. You get the idea. So these are the 2 points. And knowing the 2 points, we can always find the slope of the tangent line, right? So we are going to use now difference quotient method to find the slope, right? So to find the slope, we can say that the slope is the limit where h approaches 0. This h is very close, where h approaches 0 for f of a plus h minus f of a over h. So by definition, that is how we are going to find the limit. Perfect. So this could be written as limit h approaches 0. F of a plus h we just found is this expression, which is 2 over square root of 9 plus h. And f of a is 2 over 3. So minus 2 over 3. Everything divided by h. So that is the limit which we are trying to find. Is that clear? Perfect. Now to find this limit, let's cross multiply and simplify this particular expression. So we get this as limit h approaches 0. And when you cross multiply, you get 2 times 3 is 6, right? So we could write this as 6 minus 2 square root 9 plus h over, all this comes in the denominator. Perfect. So 3 times h times square root of 9 plus h. Doesn't make sense to you. So that is what you get. Now to solve it further, what we need to do? We need to rationalize the expressions. So we'll rationalize and say slope m is equal to limit h approaches 0, and we have all this, which is 6 minus 2 square root of 9 plus h over 3h square root of 9 plus h. So rationalize means we'll multiply and divide by the conjugate of this, right? So which is 6 plus 2 square root of 9 plus h. We could have simplified this by taking 2 common, right? So we'll be working with smaller number in that case, but I haven't done so here. but you could definitely do it, right? So we have this expression which is slightly bigger numbers. Anyway, so when you do the numerator, difference of squares, you could write this as limit h approaches 0. 6 square is 36 minus 2 square is 4 times square root square is 9 plus h over all this, right, which is 3h times square root 9 plus h times, let me write in brackets, 6 plus 2 square root 9 plus h. Clear? So that's what you get. Now, if I open this numerator, what do I get? I get slope m, limit h approaches 0. 36 minus 36. Do you see that part? So 36 cancels. So you're left with minus 4h above. So we have minus 4h over all this, which is 3h times square root 9 plus h times 6 plus 2 square root 9 plus h. Clear? So that 36 and 4 times 9 cancels. Now you could cancel the h. Once you do that, then you can substitute the value of h and find the result, right? So the slope m, when you write 0 here for h, you get minus 4 over 3 square root 9, which is 3, times 6 plus 2 square root 9, correct? Which you get as minus 4 over, this is 3 times 3 is 9, and this is 6 plus 2 times 3 is 6 as 12, right? So 9 times 12. Now 12 and this can be simplified, so you get negative 1 over 27. So that becomes the slope at the given point, correct? So this becomes the slope at the given point, minus 1 over 27. Now what is the equation of the line? Equation of the line, the tangent line, will be y minus y1 equals to m times x minus x1, correct? Using this, we can write down the equation now. So we have y minus y1, which is 2 over 3, equals to m, which is minus 1 over 27, times x minus x1, which is 6. Correct? So that is how you get your equation. And now to simplify, we'll just multiply with 27. So we get 27y minus, that is 9 times 2, 18, equals 2. Here we get minus x plus 6. Bringing all the terms together, x this side, plus 27y, bringing 6 this side gives us minus 24 equals to 0. Correct? So that becomes the equation for us. Right? So this was plus and we bring it to this side, so it becomes minus. So that becomes the equation of tangent line. Perfect. So that is how, using first principle, we can find equation of a tangent line to a given curve. I hope that helps. Question number 7. A spherical balloon is being filled with air. Calculate the average rate of change of the surface area with respect to radius in the interval 4 to 6. Part B. What is the radius of the balloon when the area is changing at the rate of 80 pi centimeter square per centimeters? You can always pause the video, answer my questions, and then look into suggestions. Here, we are interested in surface area. So what is the surface area? Surface area for a sphere is 4 pi r square, right? So you can use this formula to calculate. So let's first find what is average rate of change 4 to 6, right? So average rate of change basically is equal to rate of change with radius of 6 minus radius of 4 divided by 6 minus 4, right? So basically we can say let's use area A when the radius is 6 minus area when radius is 4 divided by 6 minus 4. That is how we find average rate of change, correct? Applying the formula 4 pi r square, we can say 4 pi radius is 6 for us, 6 square minus 4 pi 4 square over 6 minus 4, which is 2, right? So we can take 4 pi common, and here we get 36 minus 16 over 2, right? So now 36 minus 16 for us is 20, and that is like, it could go by 2 times. So we have 40 pi as the radius rate of change of area. So we are assuming this 2 units will be, we can write unit square plus unit, right? So unit square over unit is the answer. So that is part A. So we get here 40 pi unit square per unit. Okay. Now let's do part B. So this was A. Let's do part B. What is the radius of the balloon when the area is changing at the rate of 80 pi centimeter square per centimeter? So for instantaneous rate of change, we know that the instantaneous rate of change is, let me write, instantaneous rate of change is basically equal to limit when h approaches 0 for f of a plus h minus f of h, or f of a, right, f of a divided by h. That is what instantaneous rate of change is. Now in our case, we are given the instantaneous rate of change. We need to find the value of a, right? That is the equation. We need to find what a is, correct? So let's try to figure this out. So we know this is limit h approaches 0. So writing a plus h for r, that is the variable, we get 4 pi a plus h whole square minus 4 pi a square, correct, over h. That is what you get. So now we know instantaneous rate of change is 80 pi. So let's write 80 pi here. That should be equal to this limit. Limit h approaches 0. Let's expand this. So we get 4 pi. 4 pi is a constant. We could have taken it outside anyway. We'll multiply this with a square plus 2ah plus h square minus 4 pi a square over h. So 4 pi a square cancels with your first term. Then from this we can take h common, right? So we have limit h approaches 0. We can also take h common. So h times 4 pi, and we are left with 2a plus h over h. So this h also cancels. Now we can substitute h equals to 0. So we get 80 pi equals to 4 pi into 2a. This becomes 0, right? Into 2a. Now solving this, we can find the value of a. Pi and pi cancel. So this implies that a is equal to 80 divided by 4 times 2, which is 8. Correct? So we get the answer as 10. And the units will be centimeters. So our answer here is that the radius of the balloon when the area is changing at the rate of 80 pi centimeters square is 10 centimeters. Is that clear? So that is how you should be solving it. So I hope you enjoyed the journey of going through the solution of this excellent test paper where we had variety of questions based on limits. So we first understood the piecewise function, how to find limits for a piecewise function. Then we talked about one-side limits, also knowledge-based questions on calculating limits for different kinds of functions, and then we had 3 application questions. I hope that gives you good practice. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.